Okay, we're going to be working on lessons 1-8, which is going to be an introduction to equations, and then we're going to be looking also at 1-9, which is writing equations, looking at patterns, and then how would we put that on a graph, okay? So an equation is a mathematical sentence that has an equal sign. So please don't get that confused with expression. Expression has no equal sign. Equation now has to have an equal sign. We have what's called an open sentence. So an open sentence is an example right here. So this guy right down here is an open sentence. So we had 32 equals 2x plus 12. We have an unknown. And if we have an unknown, that's an open sentence. So it contains one or more variables. So again, you could have one, but we could also have a couple of different variables. And then it's going to be true or false depending on what value we give you for right now. All right, so if I'm looking at the first example here, it says determine if the given number is a solution. All right, so if we're determining if something is a solution, all we're going to simply do is just take that and we're going to plug it back in here and see if it works. So like in junior high, it had been very similar to like you checking your equations. Once you get an answer, check it. So you're going to do 32 equals, on the other side, 2 times 6 plus 12. And so our job here is to make sure that this side right here is going to equal this side right here. So 32 is good. We don't need to do anything to it. Now, sometimes I like to put like a wall down here so you can kind of see and keep it separated. Don't get confused. We're not doing anything to the 32, but on this side, we're going to go ahead and do our order of operations and try to get the correct answer here. So we've got 2 times 6 would be 12. So 12 plus 12 is 24. So now, does 32 equal 24? No, it does not. And guys, remember, when we put a slash through an equal sign, that just means does not equal. So when it's asking, determine if it's a solution, in this case, it is not a solution. The answer is going to be no. Okay? All right, so again, we're going to be given, in this case, that m equals 1/2. And we're going to take that 1/2 and plug it in for the m. So I've got 6 times 1/2 minus 8 equals 5. Okay, so now again, I don't really care if you draw a wall or whatever, but just keep in mind the 5 on this side stands as is. We're not going to do anything to this 5, but we're going to do order of operations over here and see if it works. Oh, and I just realized I didn't put, it's a -5. Got to make sure I keep my signs, right? So order of operations says we do a multiplication first, so half of 6 would be 3. 3 minus 8. So we're going to subtract them because they're different signs, and we're going to get 5, and then we have more negatives, so it's going to be -5. So does -5 equal -5? Yes, it does. So in this case, is this a solution? Yes, it is. All right, go ahead and pause the video, and I want you to try C on your own. Okay, so on this one, you should have went ahead and plugged in -8 here. So I have 9 times -8. Now I'm going to go ahead and make this double negative in the middle a positive. So I'm going to call it plus 72 equals 0. All right. And again, I'm going to work this side right here. So I'm going to start with my multiplication. So 9 times -8 is -72 plus 72. So does that give us 0? It sure does. 0 equals 0. That works. So yes, this should have been a solution. All right, the other part in this lesson that we're going to look at is we're actually going to be translating again. So we're going to be breaking down our words, but the difference is now it's asking us to write an equation instead of an expression, which means we've got to have an equal sign now, okay? So again, all of the old words that we studied back in lesson 1-1 are still in place: sum, product, difference, etc., okay? So as we start reading here, the sum. So sum means addition with parentheses. So I'm adding something up and I'm going to put it in parentheses. Now what am I adding? 4 times x, and then the word and, so that's what the plus sign is, -3. So right off the bat here, I have got 4x plus -3. Now the word is, this is something you will need to know. The word is means equals. All right, so anytime you see that word is, that's where your equal sign should be going. So I've got equals, in this case 8. Now on this particular problem, it would be fine if you didn't have the parentheses because they don't do anything in this particular problem. However, just keep in mind, it's not wrong if they're there, but it would be wrong sometimes if it's not there. So again, the word sum, addition with parentheses. All right, so let's break down this next one here. Okay, so it says the product. So product means to multiply, right? There's one of our vocab words. Product means to multiply. So I'm going to multiply. And then what am I going to multiply? I'm multiplying 9. And then all of a sudden this thing difference comes up. All right, so there's that and. That's telling you that's what you're going to multiply. But difference means parentheses with subtraction. So I'm going to multiply 9. And then the difference of 6 minus x. All right, that's a tricky one. That was a tricky one. Now, in this case, they have got is equal to, same thing. There's that word is again, right? Is means equals. Oops, that was a highlighter. Sorry, guys. Is means equals. All right, so it's going to equal 1. All right, next one. An athlete trains for 115 minutes each day for as many days as possible. Write an equation that relates the number of days D, and that means we have to use D when they give it to us, that the athlete spends training when the athlete trains for 690 minutes. So now when I'm looking at this, a majority of you would probably just tell me to divide. You would say, look, we've got 690 minutes. We're training 115 at a time. Can't we just divide those? And the answer would be, yeah. You could just go ahead and divide that and say 690 divided by 115 should give me the correct answer. Now, this does say write an equation, though. So in this case, I'm just going to put equals, and that'll give me my amount of days, D. Now, another way you could write this is to look at this guy right here and know that I'm going to go for 115 minutes for a number of days that we just don't know yet. So that word each, you're going to see that pop up later in this semester a lot. Each or the word per. All right, so each or per basically just means to multiply. So 115 each day, and then your total here would be 690. Now, most of you guys would know that we would just divide the 115 over to this side, so it's the exact same thing here. It does not matter which one of those you write. Both of those would be correct. All right, so in example 3, it's actually very similar to what we did back here in example 1, okay? So we were trying to see, does like 6, is that an answer? We plugged it in. So it's the same thing now, but now we have an x and a y. So we're going to be plugging in both our x and y value into here to see if it works. Okay, so you can have, remember, equations can have more than one variable. So when I'm looking at this, please, please, please keep in mind that your first number is always your x and your second is always your y. It's a coordinate point. Okay, so now I'm going to plug in. My y is 10 and then 4 times 3. So again, does 10 equal 12 in this case? The answer is no. It does not work. So is this a solution? No, it's not. Okay. All right, let's try this again. All right, so now on this one, again, this is your x. This is your y. All right, so now when we take this and plug it in here, we have to be really, really careful because you have a negative and then you're going to put another negative into the game there. So you have a negative and then a negative 3.1 equals, and now my y value from right here is just going to be 3.1. So equals 3.1. So now, hopefully you remember after reviewing last week that a double negative will be a positive. So this is just saying 3.1 equals 3.1. So does that work? Yes, it does. Okay. All right, I would like you to go ahead and pause the video, and I want you to try to do C on your own. Okay. So on this, again, here's x, here's y, so we're going to go ahead and plug in. So 1 1/4 equals, your x value is 2 minus 3/4. Okay? Now, guys, you can convert things to improper and maybe put 2 over 1 and do subtraction like that. But most of you guys will know that if I have 2 whole units and I take away 3/4 of a unit, that's going to give me 1 1/4. Now, if you're a person who didn't know that, it's okay. It's okay to say 2 over 1 minus 3/4 and to come up with your common denominator of 4. So we would end up, so we'd multiply this guy by 4, right? So we would end up with 8/4 minus 3/4, which would give us 5/4. And then keep in mind up here that when we go ahead and multiply, right, and then we add, we're going to end up with 5/4 on the other side. So does this work? Yes. However, I am also okay with back here if you just kind of did that in your head and you went just right away, you said, yeah, that's going to be an answer. That would be okay because that's something we expect you to be able to do in your head. All right, let's go ahead and flip over to the next page here. All right, so we're still working on equations. However, this time we're going to be putting in a table with it, and we're going to be putting a graph in, okay? So what they're going to do is just give you a little bitty description, and your job is to kind of come up with the table, all right? And that's kind of a tricky part. It's going to be tricky for some of you. All right, so Pete earns $12 per hour. Now again, on the other side there, we just talked about that the word per just means to multiply. So I'm really just taking $12 times how many ever hours I work, okay? So let's think about this for a second. A lot of times we put the X value first and the Y value on bottom when it's running horizontal like this, okay? So X value, in this case, that would be kind of the same thing as the H value, $12 per hour. So let's think about it for a second. If I work, and I'm going to go ahead and just put hour here. If I work 0 hour, 1 hour, 2, 3, 4. Now guys, you can use any numbers you want up here. If you wanted to do like 0, 5, 10, 15, 20, that's acceptable. If you didn't even want to start at 0, that would be okay too. But whatever you do, just make sure it's the same unit across. So if you're going up by 1s, do that all the way through. If you're going up by 5s, do that all the way up, etc. Okay? All right, so if I work for 0 hours, I probably should be making 0 money, right? I didn't work, so I don't have any money. So this, in other words, is going to be our money or our earnings. That didn't come through real well. That's supposed to be a dollar symbol. Sorry. All right, so now if I work 1 hour, 1 times 12 is 12. If I work 2 hours, I'm going to make $24. If I work 3 hours, I'm going to make $36. And if I work 4 hours, I'm going to make $48. Okay, so now I've got the table done, but it does ask us to write an equation. Well, we're kind of already there. We know that we're multiplying by 12. The only thing we've got to put is what is it equal to. So in this case, back up here, you could say it's equal to like your earnings or your money. Another way you could do it is just say that y equals 12 times x, okay? So it won't matter if you use x and y, or if you want to pick your own variables for right now, that won't matter, okay? So if they don't give you variables, you get to pick. All right, so now kind of keeping this in mind, and you can even see here, I left the x and y on here, just to remind you, remember this is your x-axis, this is your y-axis. All right, so on my x-axis, well, I'm just using the x numbers that I have here, okay? So I'm going to use 0. And now 0, make sure 0 is your corner. Always, this is always 0, okay? And then I'm going to do 1, 2, 3, 4. Now you could spread it out a little bit if you wanted to do like 1 here, 2, 3, 4, and spread it out. That's fine. You guys just make sure it's even units. So if I'm going up 1, 1, 1, 1, that's fine, but it's got to be even units all the way across, okay? All right, I'm going to erase this real quick down here. Just don't want to confuse anybody. All right, now going up my y-axis here, right? I'm going up by 12s. So again, since I started at 0, I'm just going to follow the pattern that I have here. And I'm going to do 12, 24, 36, and 48 up my y-axis here. So 12, 24, 36, 48. And again, are you going up by the same unit on each level? Up by 12, up by 12, up by 12, up by 12. And I don't care if you wanted to count by 10s and then to estimate where it's at. That's fine. But you have to be going the same increment all the way through, and you have to be starting at 0. Okay? All right, now go ahead and plot your points. So I've got a point at 0, 0, 112, 224, 336, and 430 or 448. And go ahead and draw your line there. Okay, and if you press and hold on Notability, it should straighten your line out for you. Okay, so now you do expect you to label. So if you read the directions right there, it says make sure to label your graph. That's part of it. We always label. So my X, if you want to look back right here, my X is my hours. My Y is my earnings or money, however you wanted to put that. Okay, so down here, I'm going to put hours for my X, always labeling. Oops, forgot my R there. Hours. And then over here you can put money, earnings, whatever you want to put. Okay? And then normally we do give it a title. So in this case, since it's Peter, I'm going to do Peter's earnings. Okay? All right, so now it did ask us to write an equation. Well, we've already done that, so if you want to go ahead and write that down there, you can, but we've already got your equation there, okay? All right, let's go through one more. So now on this one, they actually already give you a table ready to roll, all right? So that's kind of nice. So it says use the table to draw a graph, write an equation, and then answer the question. The table shows the distance in terms of hours Jerry and Michelle have traveled on their way to visit their family. They take turns driving for 12 hours. What distance will they travel in that time? And make sure to label your graph, okay? All right, so if I'm looking here, you can see that they're already telling you that 1 hour they go 67 miles. In 2 hours, they went 134 miles. Now, the nice thing about this is if we kind of look at this, what's happening here is that you're just going up by 67 every time. Okay, so they've already got nice, pretty even intervals for you. You don't have to mess with that, okay? So on my graph over here, again, your corner will always be 0, okay? So you're going to put 0 in right here, all right? And then they've been driving their hours. So if I look here at their hours, they've got 1, 2, 3, 4, 5. So I'm going to put 1, 2, 3, 4, 5 down here on my x-axis. So I've got 1, 2, 3, 4, 5. And then since they are counting by 67s here, I'm going to go ahead and just leave it as 67s. Now, it would be fine if you wanted to do something like 60 and then 120 and then like 180. But notice again, I'm keeping it in even intervals. 60, up 60, up 60. All right, so it has to be the same thing all the way up. You can't skip around there. All right, so I've got 67. And then I'm going to go ahead and put in the 134, 201. 268, and then 335. All right, so I'm going to go ahead and graph. So 0, 167, 2, 134, 3, 201, 4, 268, and 5 is 335. Okay, and label, this would be my hours, and this right here would be my mileage. Okay. And then you can go ahead and put, I'm just going to put like road trip, traveled, family, doesn't matter. As long as it applies to the problem, we're okay with whatever title you want to put. All right. So now, equation time. How are we, oh, you know what? I didn't draw my line there, did I? How are we going to write an equation here? Okay, so we're kind of looking for a relationship from here to here. What did we do? Well, if we look here, we multiplied by 67. What did we do here? We multiplied by 67, and that gave us the 134. That gives us a 67, etc. Multiplied by 67. Okay, so in reality, what I'm doing here is I'm taking my hours and multiplying by 67. So 67H, or if you wanted to say 67X, that would be acceptable. And now, what is that going to equal? It equals my miles. Okay, so when I multiply, this is what it equals. Or you could just say y equals. Okay, so now the question is, they take turns driving for 12 hours. What distance will they have traveled in that time? So we're going to need to go ahead right here, and we're going to plug in 12 and find out what our answer is. So we're going to take 67 times 12. Again, no calculators yet, so we have to do this by hand. So 4 carry 1. So we get 12 and one more will be 13. We're going to add a 0 and get 7 and 6. So 4, 0, carry my 1. So I get 804. And then in good math form, we always label. So this would be miles. So they traveled 804 miles in the 12 hours. All right, and that concludes this note.